Good afternoon, everybody. I would like to thank the Académie Française des Sciences for the invitation. For me, it's a true honor to be here at this unique event around insects. I have prepared a little presentation on insect biological control, one of the world's important ecosystem services that are provided by insects. So insects are the most specious and diverse class of animals on Earth. They lay at the basis of many of the world's ecosystems. They constitute vital food items for numerous organisms, and they are involved in a broad range of ecosystem processes. Associated with those ecosystem processes, they also provide several ecosystem services. One of those is agricultural pest control or biological control, is a service that is valued at between $4.5 and $17 billion annually for the US alone. Worldwide, this service is estimated at a value of $160 billion annually. So biological control is a very important in agricultural settings. Yeah? So the natural enemies, insect natural enemies, they regulate herbivorous pests. But biological control also helps keep our world green by curtailing the action of herbivores. So we as scientists, we recognize very well this important service that's provided by insects, and especially I think here in the audience, everybody recognizes the role of insects, but oftentimes it's challenging to convey this to other layers of society. Yeah? To convey this importance of insects and the services they provide to other layers of society. I try to remediate this, and I will try to cover how I do this in my short presentation. And I do this by drawing on a case study that involves cassava. Cassava, or le manioc, is a very important staple crop in the world. It's one of the world's major staple crops. It's cultivated on 25 million hectares globally. It's widely considered as the #3 source of carbohydrates in the tropics, and it's a multi-purpose crop. It's used as a food, as a feed, as a fiber crop, and for bioenergy. Yeah? So cassava is notoriously susceptible to attack by a number of destructive pests. One of those destructive pests is Phenacoccus manihoti. The cassava mealybug is a sap-feeding pest that's originally from the neotropics, yeah? from South America. This pest in the 1970s made its unfortunate arrival in Western Africa. In 1973, it made it into Africa, and from there, it spread across the African cassava belt, impacting cassava production and causing major yield losses at a continent-wide scale. Yeah? This pest problem, yeah, this pest invasion by the cassava mealybug, was curtailed or was resolved by the introduction of a millimeter-long parasitic wasp called Anagyrus lopesi, a wasp that was sourced in Paraguay in the region of origin of the cassava mealybug. Yeah? This parasitic wasp was introduced in Africa in 1981, was released across the African cassava belt, established in 27 different countries, averted widespread famine, and purportedly saved the lives of 20 million people. Yeah? This biological control endeavor generated economic benefits that already surpass $120 billion. And this biological control endeavor was awarded with the World Food Prize, yeah, the Nobel Prize in Agriculture in 1995. Yeah. Unfortunately, again, in 2008, this world-traveling mealybug made its arrival in Southeast Asia. So it was detected in 2008 in Thailand, and from Thailand on, it spread across Southeast Asia. In 2010, it was recorded in Java, Indonesia, close to Jakarta, and from there, it made its way eastward, reaching population levels of hundreds of mealybugs per plant and field level incidence of 100%. Yeah? These population outbreaks were reflected in major yield losses. So in 2008, the mealybug first reported in Thailand. In 2009, 2010, there were yield losses at a province level in Thailand that were between 30 and 40%. Yeah? In 2010, Thailand decided to import that same parasitic wasp. Yeah? So that same parasitic wasp was released throughout Thailand in 2010, and the introduction of this parasitic wasp led to a recovery of crop yields of 5 to 10 tons per hectare and led to an increase of farm-level revenue between $200 and $700 per hectare, all while entirely avoiding the use of pesticides. Yeah? This parasitic wasp, introduced in Thailand in 2010, established across the Southeast Asia region. Yeah? So parasitoids at present can be found from the Ayeyarwady Delta in Myanmar to Lombok, Bali in Indonesia. Yeah? Across the continent, these parasitic wasps have established. The populations of this parasitic wasp oscillate together with its mealybug host and drive down the mealybug populations below economic thresholds. The release of this wasp did not only carry benefits for the individual cassava grower, but also benefited agro-industry, and most specifically, the production of starch. Yeah? In mainland Southeast Asia, starch production or starch production is the main aim for cassava production. So cassava is widely used for the production of starch. Thailand is the world's #1 starch exporter. So Thailand exports at the global level 36% of starch. And with 99% of this starch being derived from cassava. Yeah? So cassava and Thailand, very important in the world starch market. Thailand's cassava exports reach all corners of the globe. Yeah? So in this trade wheel, Thailand is represented here in blue. And as you can see, its exports, they go to the Middle East, they go to Europe, they go to Africa, they go to South America. In this trade wheel, I omitted China. If I put in China, China eclipses all the other countries. Yeah? So this circle would basically be China. Yeah? So when the cassava mealybug arrived, this event here in 2008, following the invasion of the cassava mealybug, the 2 years after the cassava mealybug, Thailand's export price of starch nearly tripled. Yeah? So the export price of starch went from $200 per ton to $650 per ton. Following the release of the parasitoid in mid-2010, those prices dropped, the price fluctuations eased, and the international commodity trade flows normalized again. these price shocks in Thailand's, or these shocks in Thailand's cassava price had further cascading effects on the global starch market, and especially the pricing of substitute commodities such as maize, such as corn, such as potato, and as wheat. Yeah? So as you can see, I again plotted those three events: the invasion of the cassava mealybug, the first introduction of the parasitoid in Thailand, and in 2010, the release of the parasitoid throughout Thailand. Yeah? So had that introduction of the parasitoid and the mealybug invasion had very important effects at the global level for prices of commodity substitutes. And furthermore, though it's a little bit dangerous to imply causality, but the invasion of the cassava mealybug constituted the prelude to the 2010-2011 food price crisis. So here in black, I plot the price of cassava starch in Thailand, and in gray, I plot the FAO food price index. So the index that captures, at a global level, the prices of food. Yeah? And as you can see, the surge in price of the surge in export price for Thailand's cassava anteceded, yeah, or preceded the surge in prices in the FAO food price index. Yeah. Furthermore, in this graph, I show regional deforestation patterns. So deforestation patterns for 4 Southeast Asian countries: Myanmar, Laos, Cambodia, and Vietnam. And I plot real-time deforestation as monitored by satellite versus the increase in cassava production area. And again, in the graph, I visualize those 3 different events: the mealybug invasion, the introduction of the parasitoid, and the nationwide release of the parasitoid in Thailand. And as you can see, well, you cannot see because I changed the slide. As you can see, from 2009 to 2010, the mealybug invasion brought about an increase in cassava production area with 300,000 hectares and an escalation of deforestation at the regional level. Yeah? So due to a shortfall in production and rapidly increasing prices. When the parasitic wasp was introduced in 2010, prices went down, cassava yields were restored, and deforestation slowed. So the introduction of the parasitic wasp actually slowed down deforestation. So in summary, what did I try to show in this 10-minute presentation? First, biological control improved financial solvency of smallholder farming operations in Southeast Asia. 2, biological control restored yield levels and improved food security in eastern Indonesia, where cassava is an important food crop. 3, biological control saved the lives in Africa of 20 million people, improved human nutrition. 4, biological control eased price volatility in global commodity markets. And 5, biological control protected the environment at a macro scale. Yeah? So natural enemies, be they predators or parasitoids, are really formidable allies, though they often are disregarded, yeah, or overlooked. Instead, they should be actively conserved and celebrated. Yeah? Thank you.
Thank you, Chris. Is there a burning question? Just one question because of the time concern.
One of the major concerns of releasing these other types of insects is that they may have secondary consequences. So were there any consequences in addition to mealybug?
Yeah, I think that's a very good question. So the parasitoid that was released is a specialist wasp. So it's only recorded from Phenacoccus manihoti. It was widely tested when it was released in Africa way back in the 1980s. And then follow-up monitoring was done in Africa. Follow-up monitoring has been done in Southeast Asia, and it has not been recorded from any other mealybug or any other organism. Yeah? So I think maybe the only non-target effects could be at the initial release when the mealybug populations are high, when the parasitoid populations are also high, could be through hyperparasitoids. Yeah? So that you would have hyperparasitoid populations building up on the parasitoid and then maybe ultimately impacting other parasitoid species. But I think that's a transient effect because after a couple of years, mealybug populations go down, parasitoid populations go down, and hyperparasitoids will be at a background level. Yeah.
Thank you, and thank you very much.